Do you believe that we are alone in this universe? The sheer vastness of space seems to make it an impossibility. You've no doubt thought about it, wondered about it, imagined what life outside of Earth might look like. Well, the TRAPPIST-1 system may have just proven that we are indeed not alone in the universe. TRAPPIST-1 is a mirror of our solar system. It is around 40 light years away from us and has 7 planets that are all similar to Earth. What else could the TRAPPIST-1 system be mirroring? Could one of its planets hold something as crazy as alternate versions of ourselves? There's only one way to find out. We bet you love your individuality. You love being an independent thinker. You love to express yourself in your own unique way. But what if we told you you're not unique at all? That there are in fact billions of copies of you in existence. Theories of alternate universes in which each of us exists as multiple versions of ourselves all at once have abounded for a very long time. Most recently, Michelle Yeoh starred in an Oscar-winning film that gave us a peek at what that reality might look like. Well, what if these alternate versions of ourselves aren't so out of reach? What if they are only a few light years away? The sun has been burning for more than 4 billion years, long before the Earth or anything we understand as reality ever existed. It's possible that the sun believed itself to be a single entity, unique in its existence, the center of the universe. With its great power, the sun evolved. It pushed and pulled, created and destroyed, confounded and revealed. Its activities caused the formation of the 8 planets in our solar system, a system believed to be distinct, solitary, and unrepeatable. That is, until the sun could no longer feign uniqueness. Enter humans with our Earth-centric perspective that is so rigid it would make our already fiery sun blush. With our ever-growing technology and specialized equipment, we set out to crush our sun's egocentrism, never imagining that we might have to confront our own in the process. We discovered that all those stars, more than 100 billion in our own Milky Way galaxy, that we stared up at each night for millennia, were more than just twinkles of light in space. All those stellar bodies were copies of our own sun, living out their own variation of starry reality in an infinite number of ways. Our sun, the center of the universe, turned out to be no more than an ordinary star. And then the real clincher, our Earth, turned out to be just one rocky planet in a universe of incalculable numbers of rocky planets. We have discovered that almost every star has its own stellar system, with worlds that have piqued our interest. We call them exoplanets, and right now they seem to be everywhere we look. While a lot of them offer so many possibilities, excitement, and mystery that scientists are eager to unravel, we cannot possibly demystify them all at once. Recently, the TRAPPIST-1 system has gotten most of our attention, and in just a few moments, we'll show you why. TRAPPIST-1 was initially discovered in 1999 by a team of astronomers led by John Gizis. At the time, the star was not so intriguing and had a long numeric name that was easy to forget. TRAPPIST-1 was, and is, still classified as an ultra-cool red dwarf star. But not much was thought of it until several discoveries later. In May of 2016, using the Transiting Planets and Planetesimals Small Telescope, or TRAPPIST, located in Chile, scientists found that 3 planets were orbiting the star. From that moment on, the star was dubbed TRAPPIST-1 in honor of the telescope that made this discovery. The discovery of these 3 planets set a lot in motion. it held so much promise. And to find out just how much, NASA's Hubble telescope was sent to take a deeper look at the TRAPPIST-1 system and 2 of its 3 planets. The Hubble telescope revealed that the 2 planets it observed, TRAPPIST-1b and c, did not have hydrogen-rich atmospheres like our known gas giants, Jupiter and Saturn. This meant that even if they weren't exactly habitable, they were rocky and ripe for further investigation. For an even deeper look at this world that had so many similarities to ours, astronomers used NASA's Spitzer Space Telescope, along with a couple of ground telescopes, and what they found was even more spectacular. There weren't just 3 planets in the TRAPPIST-1 system. Almost identical to our solar system, the TRAPPIST-1 system was found to have 7 planets, and potentially some capacity to support life. Of its 7 planets, TRAPPIST-1 has 3 in its habitable zone, the area around a star where a rocky planet is likely to hold liquid water, an assumed prerequisite for life. These discoveries were made around 2017, and interest in the TRAPPIST-1 system grew to unimaginable heights. This was the greatest number of Earth-like planets found around a single star. There were movies and even musical promotions made about the TRAPPIST-1 system. People became obsessed with the idea of an alternate universe existing so close by. Consequently, NASA prepared more missions and research for the TRAPPIST-1 system. If this was it, they weren't going to miss it. So what happened next? We had established that the planets were rocky, and we had an idea of their locations. So all that was left was to determine the exact atmosphere of each of the planets, at least the ones in the habitable zone. A perfect job for the James Webb Space Telescope. How is a telescope able to do this, you ask? Like Jobu Tubaki, JWST sees all and knows all. By being able to locate planets and their atmospheres, JWST is a one-man army searching for new worlds that may harbor life. Using transmission spectroscopy, JWST can identify which molecules dominate a planet's atmosphere. When light interacts with a material's surface or passes through a gas, some wavelengths of the light tend to be trapped more than others, resulting in the appearance of particular colors for specific objects. For instance, the green color of leaves is due to chlorophyll's ability to absorb light in the red and blue wavelengths, while allowing green light to bounce back into our eyes. JWST's method of detecting and analyzing light is not so different. It stares at a star until a planet orbits that star. Then, as the light from the star passes through the planet's atmosphere, the color, or wavelength, of the resulting light is changed, and we are given a clue, or as scientists call it, a biosignature, that tells us what a planet is made of. For example, oxygen, in combination with other gases, such as methane or nitrogen, can create a red color in the planet's atmosphere. The presence of water vapor in a planet's atmosphere can create a blue color. The presence of sulfur compounds, such as hydrogen sulfide or sulfur dioxide, can create a yellow hue in a planet's atmosphere. It's important to note that these colors are just potential indicators of life, not proof. There are a number of factors affecting the detection of biosignatures, making it a complex and ongoing field of study for astrobiologists. However, the main molecules that astrobiologists are currently on the lookout for are oxygen and ozone, phosphine and ammonia, methane and CO2, and an unexpected combination of molecules. JWST has already surpassed our expectations for observing exoplanet atmospheres. However, even our champion space telescope is not foolproof. Even if we detect gases in the atmosphere of a rocky exoplanet, like TRAPPIST-1e, the most Earth-like planet in the TRAPPIST-1 system, accurately measuring those gases is not simple, and careful analysis is required in order to draw valid conclusions. While JWST's observations of the TRAPPIST-1 planets might yield less than exciting results, it is important to see the TRAPPIST-1 system for what it truly is: Aside from holding some of the most promising exoplanets ever in our search for life, its resemblance to our own solar system is a real eye-opener. It reveals what our lives could have been, if not for slight but significant differences in the evolution of these two distinct stars. What's more, with our background of rich and highly descriptive sci-fi movies, it is impossible not to imagine humans that developed entirely differently from us existing on one of the planets in the TRAPPIST-1 system. We currently search the universe for signs of oxygen and water as definitive proof of the possibility of life elsewhere. That is our focus, because those are the components that are essential for the existence of life here on Earth. We never stop for a second to think that maybe, if we are to find life outside of our own solar system, that it might not conform to those same laws of nature that bind us. These different life forms might thrive in a methane-rich environment and not necessarily one of oxygen. Just like fish can't survive on land, perhaps our brothers of another sun mother might find an oxygen-rich atmosphere to be poisonous. Sounds crazy, right? But if we've learned anything from our years of exploration, it's that we still know so little with any amount of certainty. And to believe otherwise is to default to our old Earth-centric hubris. The life forms that potentially exist on one of the TRAPPIST-1 planets could just be another version of us in a universe of infinite versions of us. Who knows? They are probably building a telescope right now, perhaps using their feet due to their useless hot dog fingers, capable of viewing our solar system and our planet and wondering if it's possible for life to exist outside of a methane-rich atmosphere. With over 5,000 exoplanets to explore and countless more to still discover, the possibilities are endless. Do you think life can get started outside of the presence of water and oxygen? Let us know in the comments.